Okay, let's get started. So we'll start with a quick video. The Bosch Group is a leading supplier of technology and services on a global scale. We developed the first connectivity-based wrong-way driver warning that actually detects a wrong-way driver when he is going the wrong way up on a highway ramp. Does not only warn the driver, but also the oncoming traffic who is potentially endangered.
Using Microsoft Azure was very important. It provides a comprehensive tool that had everything we need to the deployment of our system. Azure also provides end-to-end encryption for the whole solution, which is a key aspect when you are dealing with sensitive information like the driver's position.
We really like that the Microsoft Azure Kubernetes experience feels like what we have on our local machines. As a product team, we were happy to have the cloud solution architects and cloud native experts on our side from day one. They were helping us out by doing workshops, POCs, and discussing technical topics with us. They also supported us in getting in contact with the product teams in Redmond to have discussions with them on roadmaps and features we are missing at the moment.
Currently, we're detecting 94% of all wrong-way drivers correctly, and we are wrong only 4 times out of 1 million cases. We are currently covering 15 European countries, which comprise 13,000 highway entrances and exits.
We aim to create a scalable system which is globally available, which can detect wrong-way drivers within 10 seconds.
We are the only cloud-based solution for wrong-way driver warning on the market, and we were able to build up a community of close to 15 million users in less than 2 years.
Bosch and nDrive solved a problem that existed for decades now in a truly innovative way, using Azure services and IoT capabilities.
The specific goals of this solution is to improve driver safety and to avoid killings on the road.
With our solution, we want to contribute to reduce the number of wrong-way driver accidents worldwide to 0.
So, my name is Ricardo Niepel. I'm a cloud solution architect working at Microsoft and dedicated to Bosch worldwide. And I'm very proud to have Bosch today here on stage. So please introduce yourself and give a quick overview over the company.
Yeah, hi. My name is Bernhard. Thank you for coming. We're happy to be here. This is my colleague Dang. And we want to show you what we are working on. First of all, who knows Bosch? Hands up. Oh, whoa. Everybody. Who knows that we do more stuff than home appliances and power tools? Not so many people. Okay, we're going to change that. So to kick things off, I just want to take a minute and tell you something about our little startup. Our company was founded with 3 people more than 130 years ago in Stuttgart. And today we're happy to have more than 400,000 colleagues around the globe working together with us on different technologies. We believe in technology, and as you've seen, we are happy to work together on building products that are invented for life. Our company is divided up into 4 business sectors. The first one is consumer goods. That's where home appliances and power tools are coming from. Then we have energy and building technology. They do connected buildings of this size. Industrial technology, Industry 4.0 and stuff like that. And finally, mobility solutions, which is the business unit where we come from. And it makes us the biggest tier 1 car supplier in the world. So basically, we build everything that a car maker needs to build a car, except the car itself. And I don't know, I don't think the tires. Yeah. Our business unit is following a mission. Our mission is making mobility emissions-free, stress-free, and at least as far as possible, accident-free. This mission is based upon a project which was kickstarted back in 1997 in Sweden, and the project is called Vision Zero. The target of Vision Zero is to reduce traffic fatalities by 2030 to 0. Easy. Yeah, and reducing traffic fatalities caused by wrong-way drivers is one big no, a small, big, I don't know, piece of this puzzle. So what we are going to tell you today is, just in 5 easy steps, how we kickstarted our project inside of a big corporation like Bosch, released it to the public, and scaled it across Europe. And to tell you how everything started, I'm happy to hand over to my colleague Dang, who was one of the first team members.
Hello, everyone. In 2015, our CEO tasked us with a task to create a wrong-way driver detection system. Of course, the wrong-way driver event is a really rare event, but most of us are aware of it. And this also reflects in the market research results which we have conducted. In those results, the people told us that the wrong-way driver detection feature was among the top 5 features which they requested for driver safety. And so we also dug deeper into the statistical facts, and we saw that most of the wrong-way drives begin at highway entrances, nearly half of them. And if an accident occurs, they occur within the first 500 meters already. And in 2015, we concluded that existing solutions were just not sufficient enough to warn the people in time. When we look at radio-based systems, actually the warning comes like in average after 5 minutes. This is because there are no automatic detection chain available, and also the notification itself is just a broadcast, so they warn you in a very imprecise way. And in 2015, when we looked at navigation-based systems, most of the devices are just not connected, so they don't have the most updated maps, so it's quite difficult to detect wrong-way drivers where we need to match GPS coordinates to the road segments. They could change. Additionally, when we dug even deeper into navigation systems, we can see that navigation-based algorithms are really optimized for the correct driving direction. So they try to map you to the correct driving direction instead of detecting the wrong-way drive. So these solutions are also not sufficient. And as for camera-based systems, they are just affected by so many factors, exterior factors, such like weather conditions or how road signs are set up, in which angle to your camera. But also, if you consider countries that they don't have any road signs at all on highway entrances, for example, those solutions don't work either. As for infrastructure-based solutions where you have sensors on highways, on roads, they're just costly and require high maintenance. And also, they do not scale very well. So if you want to have a solution in Germany and grow to Europe and to North America, for example, they just don't scale. And that's why in 2015, we sat all together and brainstormed. And we came to the conclusion that a data-driven online service would be the best for us. So we made POCs, we grabbed our existing Bosch technologies, put all the algorithms together, and put them into our cloud, our private cloud. Made tests. We also rolled out those POCs to our Bosch fleet, and with that we could gather data from all over Germany. And we came up with the results to present them to the car makers in Sweden, where our test facilities are, and the feedback was very positive. And so that gave us such high motivation and gave us a push to create the service, which is available today online. Now I want to explain to you how the solution works in more detail. So our solution is available for many platforms. It is cross-platform. Partners only need to send us GPS coordinates, and we will do the detection, and we will also do the warning of the traffic, of the driver. For that, we have created an SDK. This SDK you can download from our developer portal and just integrate it. What this SDK does is that it has hotspots, so-called hotspots around highway entrances covered. And if a car approaches such a highway entrance, the SDK will collect GPS data and will send us GPS coordinates to our backend. And then our algorithm in the cloud will then analyze within really short time whether it is a wrong-way driver or not. And if it detects a wrong-way driver, it will inform the driver, him or herself, directly. And also it will notify, it will warn the affected traffic, and only the affected traffic only. This is much more precise than just broadcasting alerts to a region, right? And additionally, with this solution, we have the possibility to integrate third-party systems, such systems from road authorities or radio stations, to warn their audiences also. And with that, in 2015, we began as a small team, and we created the solution.
So something we have seen in this team and also with many others is that evolutionary design is a key aspect of being innovative. This was and is especially true if we want to go truly cloud native and want to leverage as many managed Azure services as it helps you. So let's take a look into the journey you had.
Yeah. So we come to 2016. Our team had grown significantly, so we were now 5 or 6 to start this service. And our target for 2016 was build a stable release of our service, build an SDK, and find customers that are willing to integrate our SDK and share data. So we started. Dang already said we have a private cloud offering, which is hosted by our central ID department in Germany and across the world. It's based upon Cloud Foundry. Many of you might know it. And we separated our service into 3 easy stages. The ingress stage, where we do authentication and validation of incoming data. The incoming data, if it's valid, is being sent to this magic map matching algorithm, the detection phase. And when the map the incoming GPS points get map matched to a database of road segments. And if we think this is a wrong-way driver by our map matching, the whole trip, all trips we got, will be moved into a post-validation stage. So we can react on road characteristics in different countries. We can do different validations on the data. And if we still say, hey, this is a wrong-way driver, then we're going to send a push over our push service, which is going out to the whole community. We had one issue during that time, and that was nobody could tell us how many people are going to go on a highway, how many people leave a highway, and how many people go through a highway. So we just didn't know how to scale our service. So we decided that we want to have an exclusive partnership over a short period of time where we gather data and then have some data available to say how we want to scale our service or how we need to scale our service if we go bigger. This was Antenne Bayern. Any people from Germany who know Antenne Bayern? Some. Antenne Bayern is a regional radio station in southern Germany. They have around 5 million active listeners every day. And when we started to partner with them, they had around 2 million apps out in the field. And we were pretty happy that they decided to implement our SDK into their app. And it was good for us in 2 reasons. On the one hand, we got data. And on the other hand, they made a marketing campaign. So they did some events, they played radio spots, they invited politicians. So it was quite cool. During that time, we were sending out our Bosch sales teams to talk to potential partners across Europe, like mostly in the app market during that time, also, of course, to OEMs. It was, for us, quite successful, and we knew we had to scale our community, and the partners were coming in, so we knew this on-prem private cloud will not scale if too many customers will come to us. So we had to start to go to Azure, you might think. Yeah, so we come to 2018, where we did our lift and shift to Azure. I mean, I don't want to go into detail why we choose Azure, because we're on a Microsoft conference, and yeah, Azure. I just want to tell you 4 points why we decided us for Azure as a team. First, it was the Kubernetes experience with Azure Kubernetes Service. It's just, during that time for us, the best integrated Kubernetes experience. It was like, okay, click, deploy, Kubernetes. The second thing is, Azure is a complete cloud platform. So we can have different SaaS and PaaS offerings where we can just focus on our core business logic and embed our stuff inside of managed services. Then, for us as community people, we are quite happy that Microsoft is investing so much into Azure. Brandon Burns, Gabe Monroy, they both joined during that time frame, so maybe this was a reason. Yeah, and the fourth thing is scale. We know that we have to scale in Europe linearly. We can go to other regions easily because Azure offers everything for us. Yeah, so we were quite happy with that, and what do you think, Ricardo?
Yeah, I think it was overall a complete success story. So I want to highlight 2 things from an enterprise perspective. What we have done since then is that currently we have 6 cloud solution architects working with Bosch worldwide, doing a lot of POCs, and we have also done a lot of reviews and POCs with especially this team. I have a lot of product group discussions about the future of AKS and all the other Azure services they are using. This is one part. The other part I want to highlight more as a best practice was that when we started with so many Azure projects and also with this project, the process of having a security review in each and individual project just costs so much time. So what we have done at Bosch currently is that we established something we are calling Azure Services Whitelisting. So essentially, the idea is that you are reviewing and approving individual Azure services regarding the regulations Bosch internally has. So they have, I would say, books and books of regulations about data classifications and security settings they want to have. So now we have a catalog, and all of the teams, and this is also true for this team, could just see which services they can use for their data classification, and they can just use it and don't need any specific review anymore. So this could be a huge time saver.
Yes, and so with the help of Ricardo and his colleagues, thank you. Yeah, we just had migrated our on-prem solution to Microsoft Azure within 6 months, which is quite remarkable from my perspective. We only did not migrate these apps to Azure, but also migrated our whole test toolings, our front end to it. It was a huge time saver for us. And the goals for our migration was that we would migrate as fast as possible with no code changes, if possible, and also to reduce our self-managed service and replace them with Azure managed service. And as for reducing the self-managed service with Azure managed services, you can see here on the picture that we have replaced our Redis solutions and Postgres solutions with Azure managed solutions. As for the platform, we moved from Cloud Foundry to Kubernetes because we think that Kubernetes is a very powerful solution, a very powerful compute platform, very flexible, but it allows us also to just use containerized apps so that we can just take our Cloud Foundry applications, just containerize them and just let them run without any code changes on Kubernetes. Additionally to this whole migration, we also added some more Azure services, such like the API portal, which we have introduced with API management. With that, we could provide our customers with a single point of entry and also handle security, authentication, and so on, fleet management in a more separate way, more clean way. Also, in order to solve the requirements which Bosch has set upon us to have network layer isolation, we have introduced Azure VNets and have segmented our solution into subnets. And now I want to give the word to Bernhard, and he will show you a little bit more about how a solution looks like.
Demo time. Now it's getting interesting. On the line, so like a Bosch. Yeah, we told you that we have a service which is running, and that's why we want to show you that we are really live. It's not a PowerPoint product. This is a map we are using for our internal development. We have an overview. Every of those blue points is basically a person who crossed a highway hotspot, as we call them, in the last, I think it's 2 or 3 minutes across Europe. I can zoom in, for example, to Ricardo's hometown, Cologne, and I will enable the hotspots. Do you see there those red boxes? These are the hotspots, and these boxes are basically inside of the SDK. So we only get data when somebody is inside of one of those boxes. We do not track you outside of those boxes, no. The SDK also generates a unique ID every time you enter a new hotspot. So we cannot track you across hotspots, except that one guy in Tenerife where there's just one highway and there's one guy going. It must be a taxi driver or something. Yeah. Do we have one here? Yeah, we can dig deeper with this UI into one of the one-way driver we basically found in the last year. This was a person who started here, and then he basically moved onto the German Autobahn. It was in northern Germany. And you see the different colors. It's a little bit small, I think, on the screen. It's basically what we matched the person to. It's on the road, it's on the highway, it's on the ramp. Or when it's getting red, it's a wrong-way driver. And what you also see is the road segments and how sure we are that the person is on this road segment. Yeah? That's the different lines that are changing all the time. Yeah. And to show you how this looks like if in live, I prepared a small video that I will just show you in a second. So what you see here is another drive, which was a wrong-way drive, and we simulated it again so I could show you the demo. And on the right side, you see the green is basically a customer backend where we can send a business-to-business push to, and you will just see, and in the lower right, you see how it's implemented in an app today. So I will just shoot the video, and I think it explains for itself. So the points are incoming. Everybody's happy driving down the road. And now the roads get out of each other, and now there was the first point where we said, oh, he might be a wrong-way driver. Now the push is out. So our target is to be below 10 seconds. So we need to have this push in the car before you're on the highway, because 500 meters is about 10 seconds. That's it. Thank you. Back to Dang.
Yes, what did we learn during this process? What did went well and what did not went well? As for us, the migration to Azure Kubernetes Service was a full success. It was really stable for us to use. With that, we could with Azure AKS, we could just spin up clusters, scale clusters, and also we could just upgrade to newer Kubernetes versions instantly, and it just works out of box. Additionally, we have introduced Azure API management. We have tested it. We have simulated 10,000 of concurrent trips with it, and it scaled also very well. So it was very sufficient for us. As with Azure Container Registries, with this service, they provided us a private image repository, which is seamlessly yeah, we've been working with our CI/CD infrastructure, and also it's just seamlessly been integrated to AKS also. During this whole migration, we also have employed Azure monitoring in our system, which is nowadays still in use, and also we have implemented for some parts of our whole system infrastructure as code with ARM templates and Terraform scripts. So overall, we've learned a lot. And yeah, because we actually are a very small team, around 5 people, and we had to make the solution working in a very short of time. Our architecture actually was not that well designed from the beginning. So our architecture after the migration was still lacking in streaming functionalities. We had problems to scale because we didn't separate hot and cold paths. Where with hot path I mean that we have to detect the wrong way driver really in real time within 1 second on the backend side. And with the cold path, I mean that we have data analytics processes in order to optimize our map matching algorithm based on machine learning concepts. So our whole architecture at that time was really not designed for that. And at the beginning of our migration, we intended to use Cosmos DB with the Mongo API as a replacement for our MongoDB, but it turned out that it was just too costly for us to use. So yeah, we didn't use that anymore.
Can you give a little bit of details? What was the reason why it was too costly?
Yeah. Cosmos DB was really promising for us, but unfortunately, when we designed our data structures, we optimized them for MongoDB queries, and it turned out that they just took many request units on Cosmos DB, and it was good, but it was just costly for us, cost inefficient, and we didn't want it to change the code, to change the queries just for Cosmos DB at that time. Also, at that time, the Mongo API support was not fully available. There were some features which we have used, which was not supported, so we just scrapped it. Let me go on. And so after this migration, we really had time to refactor and to increase, to improve our whole solution. And there were 3 challenges I want to explain to you a little bit more in detail. The first one is the decoupling of hot and cold path. Like I said, we had to separate the real-time detection and also the data analytics part. The second one was more subtle because our map matching algorithm actually requires stateful streaming. This means that our map matching algorithm just not only looks at the current position which comes in from a trip, but it also needs to look into the history of this trip in order to really map match in a very precise way in order for us to detect. This required us to have states, to store states at the backend side, right? And for that, we use local sessions to be performant. And if you use local, or if you store your sessions locally on instances, you need have to kind of sticky routing or some kind of routing of your ingress, right? So this was also a requirement. And the third one is due to the fact that our first customers use HTTP, and for each GPS position which they send us, they may use separate HTTP calls, and this has the effect that from our backend perspective, those HTTP calls could just arrive in a wrong order, and our algorithm also needs to look into the history of this trip, and it needs the correct order. So for that, we needed also like a queuing, waiting mechanism, which works in a lively way. And bottom line is, we just needed a streaming platform. Yeah? And so we have evaluated different streaming platforms, technologies, and we concluded that we use Kafka on HDInsight for that, because Kafka is like Kubernetes, an open source, and also backed up by a huge community. So that's why we went with it. And so in 2019, we re-architected our whole solution to a more cloud-native solution. And this is how it looks like. On the top part, you see the 3 components which now get their data from Kafka topics, right? This is the hot path. On the bottom part, you see the persistence box here, which is symbolized, symbol for our code path, and it also gets the data from the Kafka topics. We choose Kafka topics as a separation point here because it is very scalable. It is basically just an append-only event logs, right? So it's very scalable, and with that we can scale into many, many thousands, millions of messages concurrently. As for the stateful handling, we have used Kafka Streams framework in order to partition the ingress and store the states locally, and it worked out well for us. This is actually only a small part of our whole system. Let us now zoom out what our system is composed of.
Yeah, so essentially there are a lot of different Azure services used around these core system, I would say. We just want to give you some examples what they're also using for the overall solution. You can see on the right top, they're using also app services and front-door and AD authentication for the front end you have seen, for the map update processing. On the bottom, you can see there's using for the live system, but also for the analytics system and for the data scientists, multiple data services Azure provides. So there's a lot around these core system. Yep.
Yeah, and with that, we are currently in the present now. Our system nowadays is being used in 70 countries by 17 app partners. And in whole Europe, or those 17 countries are mostly in Europe currently, and for those 17 countries, we have generated around 13,000 hotspots. In Europe, there are around 13,000 hotspots. And with that, we have mostly of Europe covered for the highways. And we have around 1 million active users actively sending us data per month. And as you can see here in the middle, we have an average detection time when the data comes into our backend of 200 milliseconds of detection time. So we really are a real-time detection system. And we process around 6 million GPS positions daily and get around 60,000 trips daily. These figures may rise very quickly. That's why we need scaling for that, because our service is currently also being very quickly adopted by other partners. And as a whole, our service is really optimized towards a high true positive rate. So we don't want to warn you wrongly if we should falsely detect someone, because it may lead to some accidents if you see wrong detections. So our true positive rate is here really high at about 92%, and the false positive rate is really low of 0.0004%. And during our 3 years time now, we have already seen 10 million trips in Europe and really have detected 12 wrong-way drivers. 2 of them Bernhard already showed you. And to tell you more about our road ahead, I will give the word to Bernhard.
Thank you. Yeah, so now we have this stable service running on Azure. We're ready to scale. We're ready to roll out into new markets with our service. And so from the business side, of course, we are integrating new partners at the moment. We're actively looking for new partners. So if you have an app and you want to save your users' lives so that they are still your users, check us out. On the other hand, inside of Bosch, we're working on packaging, because, I mean, we are just one team. We have a lot of other teams that are working on connected mobility solutions, like, later. So we're working on packaging all those services together, and we're going to sell those to OEMs at the end of the day. So connected cars will come. It just takes a while. Yeah, they will have it in their head units or wherever. But for us, we're techies. That's why the technical challenges that we want to do or we want to tackle over the next weeks or months. First, it's elasticity. I mean, I was quite happy that we had so many people on the road when I showed the demo, because in Europe, most people are at home and they don't, already asleep. So when I checked yesterday, it was like 13 people driving around, which wouldn't be impressive. Yeah, so elasticity is a big thing for us. We are looking into virtual kubelet, by Azure container instances, just to make our cluster scale up and down more easily, so that we don't have to pay that much at night. The second thing is our algorithm guys, they now have this big lake of trip data. We're at the moment working on tagging the data, so labeling them. What was it? Was it a drive-through? Was it an entrance, leaving? Yeah, they want to do machine learning. They're like, yeah, do it. Yeah, we want to use machine learning to make our post-validation phase even better and easier to handle, and yeah, just to do some data analysis. Then the third thing is persistence. You saw this little box on the bottom, which at the end of the day, it's Azure Data Explorer, what we are currently implementing. So we're sending all the data over to Azure Data Explorer. That's why the team from Azure Data Explorer invited us to their session on Friday. It's also a lunch session, and it's short before the conference ends. So, but maybe if you're interested in Azure Data Explorer, you can join. We will show what we are doing with our data, and we will give you an overlook of some other service that we're currently integrating in the Azure Data Explorer, some visualizations and so. Yeah, and then on our roadmap was monitoring. We decided us for open tracing, just to get a better look into our service, maybe make it even better for our SREs to handle the running service, to make it easier if something happens. But I think Ricardo will have a meeting in the upcoming weeks with us so we can have a look into Dapper, because it looks really promising, so maybe we will just wrap all our stuff into Dapper over the next coming of weeks. Yeah, we were pretty fast. First of all, thank you all that you have joined us for our session. So if you want to help save some life with us, we are here, we are at the conference, or you can just mail us. And we're open for questions, or do you have some final words?
Only big thank you to Bosch overall and to the team. Yeah, and if any one of you has some questions, come up with these. We have some minutes left.
Nobody?
Yeah, I think you can just go to the microphone, then everybody can hear it.
You had mentioned some issues with the MongoDB and Cosmos DB. I mean, some issues there. Did you have any issues with KS? Any stability and?
Okay. Like I mentioned, when we began migrating to AKS, it was not generally available. It was around 2016. But at some time after, during this migration phase, it became GA, and we have used that, and we were really happy. It was stable, like I said, and what I perceive from Microsoft is that they're really, really innovative and early adopters of what is new going on in the Kubernetes community, and also with the support, great support from Microsoft partners, yeah, we are really safe. We feel safe that that we are having great support. So
one cool thing for us, I mean, we are this huge company, and we have dedicated people working for us. With them, we get a really direct connection to product teams. So when we have issues, okay, we can open a support ticket if it's something small. But if the problem is a real problem for us and the ticket is just not working, then they help us to get in contact with the people in Redmond. So this helps a lot. And as Zhang said, updating patching during pre-GA, I mean, we had to recreate a cluster once in a while, which takes 15 minutes. It's just some IP addresses. It was good. We had no issues. So
I think an important part is that you try to automate as much as possible. I think this is one thing which helps a lot if there is an issue, and you can just say, okay, I will recreate the cluster, and then it's all fine again. Something which I also want to mention is that they don't have any long state inside the cluster, because the state essentially is in the current architecture in the Kafka topics, and these are in HDInsight outside of the cluster. So I think this also simplifies a little bit the overall architecture, and also relates to a more stable version of it. Because as you all know, when you're starting having state in a big cluster, then just creating something new is not so easy anymore.
I mean,
one other thing, unless you have more to add.
One little thing. What you've seen is our basic stages, the apps always stayed the same. We just exchanged how they are run. So, and maybe in the first thing we used RabbitMQ, then we used HTTP, now we use Kafka. So, but this is just taking a library and using another library. So it was really easy for us. And so we just have our core business logic where we focus on, and the rest for us is we use the best tool for the job. Or we try to always use the best tool for the job. Okay.
You had Databricks in that architecture as well. You guys using that for your detection?
Databricks?
Yeah, I thought I saw Databricks.
Yeah, we use Databricks for two things. First, we do a monthly import. I didn't mention that. All the hotspots are generated out of OpenStreetMap data. So they are freely available over our API management. So you even don't have to log in. It's just free data for us. And we do a weekly download, basically, of OpenStreetMap data. And we generate our map databases and stuff like that with Databricks every week. So we always have the latest and greatest data from OpenStreetMap to map match our service against.
Yeah. So it's not part of the core system, so the live system. It's some of the systems around to making sure that the data is prepared correctly for the live system.
Yeah, but we will make use of it in the machine learning part, because we will try to the map matching. Yeah, we want to do experiments to tweak it, to make it better, and we will use Databricks there, just to take all our trips and just map match every point we ever got. So that's where we will use Databricks.
Cool. Another question on the right side.
okay.
You mentioned you had some issues with Cosmos and cost, and with the data structures or not being optimized for Cosmos. What did you end up doing with that? Because I've got a team right now that they want to migrate off of Cosmos to MongoDB because of the cost. And originally they started using the Mongo API on top of Cosmos, and they were having some, they weren't able to write the queries they wanted to write them, and I thought it was something like joins or aggregation or something, and then they did rewrite them to work on Cosmos, and now they're like looking on getting off of Cosmos again because of the cost, was really high.
Yeah, so like I said, we gave up on Cosmos DB because queries with aggregation and range queries did not went really well. It was not supported, and like I said, Cosmos DB, even with the lowest configuration, with eventual consistency and so on, it has just caused too much cost for us because of the request units which was required. And nowadays we ended up after that we just hosted our MongoDB clusters by ourselves again, and nowadays we have switched that also, and now we store our data in Azure Data Explorer, which is a good suit for us. Yeah.
Got it. So you're not, I guess I'm not that familiar with Data Explorer yet. So.
No.
Yeah.
No. I think we had one big query that used the aggregation framework, geo queries, and it was a thing like this. And during that time, we just for testing, we scaled Cosmos to the biggest thing we got. I think it was more than 20K per month. The query still didn't end. And then we were like, okay, our query does not work at the moment with that. So we need to go on. We are small. We had other issues. We want to go live. And so we just said, okay, set up a VM, set up a Mongo cluster by ourselves. And it worked. And we had to handle it. But now we're fine.
Got it. Thanks.
Okay, thank you.
Thank you very much.
So thank you all. If any other open questions, we will just be around before the session room, so you can just ask them. So thanks a lot.